Hi, everyone. Thank you for attending this webinar. I think the notice sent to you the beginning of the week telling you this is like a dual rate transceiver. Now the topic actually is multi-rate, and it's a little bit confusing, isn't it? That's how I feel also. So we'll try to gives you some clearance on this, and so we have a better understanding what dual rate or multi-rate transceiver is. So basically, I'm going to talk about two big topics. One is what is a dual rate transceiver, and then I'm going to show you different types of multi-rate transceiver. So I use dual rate and multi-rate exchangeably, so excuse me. Yeah. So what is a multi-rate transceiver? So basically, a multi-rate transceiver can support the different data rates, right? For instance, SRP plus, you can see there's a 1G, 10G, and SRP plus SRP 28, and there's 10G and 25G, and QSRP plus is 10G and 40G, and QSRP 28 is 40G and 100G, etc. The advantage, you all know that there are basically three areas. One is to allow the current structure to maximize the operating flexibility, so you can operate at different rates without changing the equipment. Secondly, and it will easy the transition from low to high data rate migration, and yet keeping it backward and forward compatible. You don't have to eliminate the low rate system. And also the third one is also important. That's where the saving money comes in, and to simplify the parts inventory. So those are important areas. And now I'm going to talk about different types of multi-rate transceiver. The first type is rate RS stands for rate select. So rate select to change the operating parameter. So when you change the rates, and there are operating parameters within the transceiver to be changed also. One is the first one is the receiver bandwidth, and also the transmitter extension ratio, and also the laser bias current, because they all has to do by the standard. And I will explain this a little bit more later. And so the data sheet, which you mean the specification, should include the extended data rate parameter. And it should be compliant to the MSA standard specified. For example, this SRP plus 1G to 10G dual rate transceiver is an example of this group. The second one is the rate select, but not to change the operating parameter. I will explain this a little bit more again. It just simply bypass the CDR. Therefore, the specification in the data sheets might not include the extended data rates, and because they might not be able to meet exactly the data rates of the other data parameter, and it may not be compliant to MSA standard. Example is 10G multi-rate, 2G, 4G, 8G fiber channel, 10G, 40G, and 10G, 25G. And the third group would be you don't even have to change the rate select. Once you plug in the transceiver, the CDR would detect the different data rates and automatically switch to bypass mode on the CDR. So one of the product I see is the 40G to 100G transceiver. You plug it in, and it's automatic switchable for you. So the third one is like that, and the fourth one is by inherent design. And the design itself maximize the data rate, extra state data rate specified. And it should be compliant to MSA. The data sheet should include the extended data rate. The primary example would be the Ethernet and ONT and OTU rates, Ethernet, separate, and fiber channels rates. That one you don't have to switch anything. So let me go to the other slide, which would explain a little bit better. And the rate select to change the operating parameter. For instance, the first group is SLP plus 1G to 10G, right? 10G is the primary data rate as specified. You can see here, 1G, the transmitter power is -9 to -1, extension ratio 9 dB, and sensitivity -17 dBm. And yet, 10G data rate is from -5 to -1, extension ratio is 3 dB now, and sensitivity -11 dBm. So you can see why the parameter had to change in order to meet the standard on both 1G and 10G. And those three areas, they need to change it. So lucky enough, they are able to do it in 1G to 10G platform. And one thing to just very interesting to show is that actually I put down here because it shows the noise, the sensitivity. Basically, it's a sensitivity, it's a noise power. The minimum noise power is like that, equal to noise equivalent power times the square root of bandwidth. When you do 1G to 10G, the difference is about 5 dB. You can see it's very close. So that's what this comes around. So they need to change the parameter to make up this 5 to 6 dB difference. And the next one is that the SLP plus 10G multi-rate. And on this one, they probably is the same thing, but they test it differently. The testing would be done less than 4.25 gigabits per second, or bigger than 4.25 gigabits per second. They present two different data here. So, but basically they are the same nature. Okay. So let me move on to the second group, which is you change the rate select, but the operating parameter is not changed. And here's the reason why. So for the 10G and 25G SLP 28, and you can see they are very close, 10G and 25G MSA. You can see the extension ratio is the same, sensitivity only 1 dB off, and transmitter power, you can make them the same actually in the middle. So that's why this group, they change, they bypass the CDR, and that's all they do. And then they provide the flexibility of running a second data rate here. So always from high to low, right? So this group is the same almost. You can compare 40G to 10G here to change, and then 40G, that means it's 10G, right? 10G, you compare 10G to 25G, is basically the same one here. So, but the aggregate data rate is 40G and 100G. Sorry about that. So basically, you can do a CDR bypass without changing anything, and you get the benefit. And the following slide, I just show how it's changed, which is presented in the other webinar in like September 10, which is available in our website to download. And I talk in that webinar, I talk about the CDI bypass mode and shown here how it's done. And the next one is a little bit more close to reality. And the eye diagram on the first row shows how the 10G data rate is passing the 25G channel with the CDR still in place. You can see the CDR try to lock very hard, but it cannot, right? You can see it try to lock very hard, cannot. So what you have is a fuzzy eye. But it's the same device, same time measure. All I did was to bypass the CDR. Once the CDR get bypassed, the 10G channel becomes like this. Of course, the scale is a little bit different. I scale it different, but you can see the jitter, right? There's no longer any clock try to lock. So even though the jitter is a little bit more, but since the 10G data has 2 and 2.5 times the width of the 25G eye, so you should have no problem of passing with the same sensitivity actually. Yeah. So again, this is presented in my other webinar. If you're interested, you can go to our website to download it. And let me see. Yeah. Okay. The last slides I want to talk about a little bit is more close to the user point of view. There are 2 standards. That's why it's a bit confused, right? For some customer to change the rate. The first one is the old MSA is 8472. And you can see in the old way to do it, first of all, you have to make sure the transceiver has the rate select identifier compliance, which means it would support the rate select. And you go to tables, the lower table, the byte 13, and if it's OE for this bytes and the 118 bytes altogether, bit 3, and you can safely assume the rate select is supported. So then you go to this 110 and 118 is representing RS0 and RS1. You can see the logic table here. You have 00 is all bypassed, and the 11 is all engaged. And in the middle, I see some transceiver in the middle that they give you more options. Since nowadays the CDR is separated into receiver and transmitter, so you can have 4 combinations of CDR operation. Okay. It's easier to troubleshoot when you have a tool like this. And the second one is more up to date, the 8636, basically grow out from the QSRP 40G and 100G and up. And here there is a little bit more involved. So there are 4 areas and you need to check. First of all, you have to check the byte 195 bit 5. If it's 1, that means the rate select is supported. And you go to another area to check out what type of rate select you're going to have. You have the extended rate select, and you go, if it's 10 on byte 221, bit 3 and 2, right? You can come back to this slide and check it out later on if you can remember. And then you go to the rate select, and then here is separated into version 1 and version 2. Version 1, I believe, is this type of rate select, and version 2 is a new one. You can see version 2 is separated into 4 links, and it's a little bit more complicated, but it's pretty flexible. So you can see you can change to different data rates, either receiver or transmitter, and or which link you want to change it. And so takes a little bit more practice on this 8636 rate select. But once you get it, you don't. For instance, most of the people would just do 00 or 11. So that's how it is done. Between 10G and 25G, you can see here, right? If it's 25G, you 11. 10G, you just put in 00. So yeah. So here, the last two pictures I want to show you just how the IC is used to change the bandwidth. You can see the bandwidth get changed. This one is like a 10G limited amplifier. They change it in the limited amplifier because for 10G, the TRA is very hard to do a bandwidth change due to the parasitic. And on here, you can see the table. You change the register setting, the bandwidth start to change. So this is a pretty good IC to support rate change. And the next one, I'll just show you again, another IC, you do the rate change, and you do the extension ratio and transmitter power change. You just flip to another set of register, and it will change for you, right? They call it lookup table. So that's how it's done. So again, in this presentation, I'll show you different types of multi-rate transceiver and what they are basically. So here's the end of my webinar, and let me see if you have questions for me. There are no questions. You can type it in and I will try to answer you. Give you a minute or so. So as the data, I think with the CDR bypass, almost you can go to much higher speed on this. So it's, and I'm sure, you know, the 25G and then other multiplication of this data rate would get rate change later on. Yeah, so it's totally possible. It just simply bypass the CDR. Okay, here's the end of my presentation, and thank you for listening.
Yeah, I think we have one question that came in just now. Can you see that, Eric?
Oh, yes. Yeah. Let me read it. So do you suggest using a multi-rate transceiver compared to single rate if the cost is not a constraint? Yeah, so one thing my presentation emphasized is the performance difference. If you try to meet a certain MSA, you must make sure the multi-rate transceiver can support it. Sometimes they cannot. You need to do that, and you make sure that they in the data sheet, those specs are specified. If they don't, it might not be a compliant transceiver. Yeah, so it's all specsmanship. You need to be very careful when you select a multi-rate transceiver. Thank you.
So thanks everyone for that presentation, and thanks everyone for joining.
Thank you.
So we had sent out a survey last week and to get some input on these webinars. I just wanted to thank everyone who responded with their comments and feedback. If you have any questions on this topic or any other suggestions, let us know. info@vtextech.com, our email address. As I said, the webinar recording will be up on our website tomorrow. So I dropped a link to that in the chat box. So thanks everyone once again, and we'll see you in a couple of weeks.